Oh, yeah, you don't have to know any of it. Yeah.
Okay, we're going to start with, I don't know if you want to call this like warm up. I'm going to start with a review of a problem on geometric stuff. I don't know if you want to call it warm up or like practice problem, or if you don't want to title it all, that's fine as well. All right, so a ball is dropped from 6 feet. And it bounces 3/4 of the height each time. So each bounce is less and less and less, only 3/4 of what it was the last time. We're gonna find the total, because again, infinite series, we're adding it up forever. Find the total vertical distance that the ball traveled. Find the total vertical distance. We're gonna draw a picture because I need one. The visual helps. It's not going to be a great picture. I'm not a great artist, but it's going to be like of a ball bouncing, right? So it gets bounced from 6 feet. So this would be 6 feet. It bounces, and then it's going to bounce less and less each time. So do you see how I'm making these like smaller and smaller? We just need to figure out the pattern. So if it does 3/4 of what it did previously, what would be the height on this? Like, I guess you could call that the first bounce because it only bounced once. What would be this peak here? Yeah, 3/4 times 6. So 3 times 6, 18. So 18/4. If you want to reduce that, I guess you could 9/2. Sometimes it doesn't really matter if you reduce. In fact, I think when we go plug it in the formula, it's going to be better if we don't, because then you can get stuff to cancel. And then do that again. So multiplying by 3/4 again, what would it be? 27/8, and so on and so forth. You can keep going as many times as you want. What we want to do is add up the total vertical distance. Now it got dropped from 6 feet. So the 6 feet doesn't count as vertical here. It only just got dropped from there. So I'm going to do 6 plus and then start the series, because that 6 is kind of like on its own there. Okay, so it is the first term. I'm going to keep that 6 kind of separate from doing this whole infinite sum here. It's the first term, which I'm going to use the 18/4, and you'll see why in a second, because we're going to get some stuff that cancels. 18/4 over, and then what would go in the denominator? It's like the homework we were just going over. 1 minus, good, r, and r is 3/4. Oh, I missed something though. What did I miss? Because that'll give us these vertical distances, but it goes up and it goes down. What did I miss? We need 2 of them. Good, I just realized that. So 6 plus and then double that, because it goes up and it comes down. I'm so sorry. All right, so let's sort that out. 6 plus 2 times, all right, 18/4 over 1 minus 3/4. That would be 1/4. And that's why I said, let's keep the 18/4, because then what's going to happen? Yeah, 4's canceled. That would just be 18 times 2 would be 36. So what is that, 42 feet? So that's just a warm up, kind of like a real world problem using a geometric series. Okay, the 2 things that we're going to do today, we're going to do the nth term test and the integral test. So we'll do the nth term test, and then I'll give you a break, and then we'll do the integral test. All right, so here's your nth term test. If the limit as n goes to infinity of a sub n, and that's just the part that's inside the sigma, just that part. If that's not 0, if it comes out to anything on God's green earth besides 0, 3, 2, 1/2, -7, infinity, It doesn't matter. If it's not 0, then the series diverges. If it is any number except 0, then the series diverges. And if the limit as n goes to infinity of a sub n is 0, then there's no conclusion, which is like womp womp, because unfortunately, wouldn't you want to be like, oh, so it converges, but not necessarily. It might and it might not. There's no conclusion that you could make. That's really it. If you can do limits to infinity, that's really all that this is. We're just going to practice a couple of them. I just have like a handful of problems we're going to try. You do the limit and state what your conclusion is. Actually, let me go ahead and write out all the problems. You can just copy them down because they only take like a second to do. So let's just write them all out first. You guys are going to be so good at drawing sigma. That's why for a lot of this stuff, you're going to handwrite your notes because typing it is so annoying and it doesn't even look nice. Really, it's, well, it used to, if I can complain about Word for a second, the old equation editor, they looked really nice. The new equation editor does not draw it very nice. It looks awful. And so anything that I want to like create or tweak from, you know, last year or change, like it just looks so bad. Yeah. All right, so we're going to do the limit as n goes to infinity for each of these. If it comes out to 0, you know, we don't get to make any conclusion. But if it comes out to literally anything else, we get to say that the series diverges, right? So for this one, limit as n goes to infinity. Now, technically, you should rewrite the thing 2 to the n. So I'm going to do that. I realize that's redundant because you're going to end up writing all of these twice. If you just want to write a sub n, I will allow that. Okay, but what would this be? As n gets bigger and bigger and bigger, what is this going towards? Infinity. So what do we get to conclude? Now, as foreshadowing, and this unit is probably seeming okay right now because we've only done geometric and we did telescopic series and now we're doing the nth term test. There are like 10 different tests and you have to know which one to apply to which problem and keep them all straight. And whenever you use them, you have to justify that, to justify your work. So we're going to say diverges by nth term test. Because you're going to have all these tests and you're going to say it converges by the integral test, or it diverges by the limit comparison test, or it converges by the ratio test. There are all these tests that you're going to have to know. So you need to start getting used to them now and justifying them that way. Okay. All right. So this one, limit as n goes to infinity. I'm going to recopy it because I'm going to post these notes online. But if you just want to write a sub n, I'm cool with that because it says the exact same thing. Like you're writing the same thing twice. So like I get it. What's that? I don't see why not. I mean, that is a sub n. So. All right. Now you have an n factorial in the numerator and an n factorial in the denominator. So that's a tie. That means we're going to use the leading coefficients. And so this would come out to be 1/2. Good. Which is not 0, you may have noticed. So we get to conclude diverges by nth term test. We are using the nth term test, which is this. If it comes out to anything other than 0, we get to conclude it diverges. Yeah, that's a really, really good question. Oh, yeah. I don't have a good answer for that. yeah, you kind of just need to look at it and see what's going on.
Will it tell us specifically that we have to use it? No.
You're going to get like a page of problems that are all mixed up together and you have to figure out what you're doing. Okay. All right, this one. Limit as n goes to infinity of 1 over n. So as n goes to infinity, where is this headed? 0, which unfortunately means no conclusion. By way of being thorough, though, this actually diverges. Do you remember when I showed you the p series? If not, that's fine. It was months ago. This is n to what power? It's n to the first. If p is 1 or smaller, it's going to diverge. If it's bigger than 1, it's going to converge. And we're going to get to the p series again, too. We'll cover it again. But anyway, that does diverge. But for the nth term test, no conclusion. All right, number 4. Limit as n goes to infinity, ln of all that stuff. And again, if you just want to write a sub n, I'm cool with that. Because I get that it's redundant. So there's an ln out front. Let's ignore that for a second. Just look inside. As n goes to infinity, what are you going to get just for this inside part? Good. 3 over 3 would be 1. So this comes out to ln of 1, which is 0. So no conclusion. Now for this last one, see that -1 to the n plus 1? That's what makes it alternate. So you would have a positive term, negative term, positive term, negative term. You can ignore that part as you go out to infinity. That's just what's going to make it alternate. And we're going to cover alternating series in more depth as well, but you don't need that part, okay? So we're going to do just limit as n goes to infinity of this part. So really, this is just a review of limits to infinity is mostly what we're doing here. And what is that one going to come out to? 2/9. So what is our conclusion? Diverges by nth term test. Correct. Since they were both n to the first, you would use the leading coefficient, so 2/9. But again, if it's anything other than 0, then it's going to diverge. Right, so if your function is positive, here I'll write the whole word, continuous, and decreasing. And like a lot of times, and you'll see when you go to do your homework, they'll say that in the problem. This function is positive, continuous, and decreasing. So that's like a big hint for you that you can do the integral test. Then the infinite series and the improper integral either both converge or both diverge. They either both converge or both diverge. So what you can do is do the improper integral, which we've covered, we're going to review it. If you get an answer, then you can be like, yes, the series converges. And if you don't, like if it goes to infinity or something, then you would be like, no, the series does not, it diverges, does not converge. So they would both do the same thing. So basically, this is going to be a big review of improper integrals, doing antiderivatives and stuff like that. So let's try a few. And I know someone is either thinking this or about ready to ask it. Can't we just do the nth term test? Because that was a whole lot easier. Let's talk about it real quick. If you did the limit as n went to infinity for this, what would you get? 0. Just as a heads up, they're all going to be 0. So the nth term test won't work because you would get no conclusion for every single one of them. Okay, thank you for heads on. Because the question is, does the series converge or does the series diverge? So if you get no conclusion, that doesn't tell you what it does. So it doesn't answer the question. Yeah, and I'm sorry, I guess that's my fault. I haven't been clear enough on that. The question for all of these, the directions for all of them, does the series converge or does the series diverge? That's the question for all of them. That's what we're trying to figure out. So no conclusion is not an answer because that doesn't tell you one way or the other. Okay. So we're going to do our improper integral. It is limit as b goes to infinity. I know it's been a while since you've seen these, but after we do a couple, I'm hoping it comes back to you. Integral from 1 to b, because it would be integral 1 to infinity, but you can't have infinity as one of the boundaries. So limit as b goes to infinity, integral from 1 to b. And then I guess I'm not going to argue with you over what letter of the alphabet to use, but I always change it to x because we're just used to using x as a variable. So I'm going to write x over x squared plus 1 dx, just because that's how we normally see it. And I just feel like that goes better. You want to leave it as n, I guess you would put dn at the end. I don't know. I feel like that would look good. All right, now we've got to get through that. It's going to be a u substitution. What are we going to let u equal? X squared plus 1, perfect. Du would be 2x dx, and we're going to adjust that with a 1/2. I don't have my highlighter out here. I'll just underline. So we're replacing the x dx with 1/2 du. Now what I tend to do is like leave off the limit while I do this substitution, so it's not like too much at once. I'll bring it back. 1/2 goes out front, du goes at the end. What's still there? 1 over u, perfect. And so what's your antiderivative of 1 over u? ln, good. So this is gonna be, I'm gonna bring the limit back now. Limit as b goes to infinity, 1/2 ln of u, which is this x squared plus 1, such that 1 to b. And then we're going to do upper boundary minus lower boundary, and then evaluate the limit. So I usually draw in the parentheses for upper boundary minus lower boundary. It's just a way to stay organized. Upper boundary is b, so you're basically just going to recopy that, except put b in there. Lower boundary is 1, so that's going to be 1/2 ln of 2. Once it's a value, you don't need to put the absolute value anymore because absolute value of 2 is 2. All right, and then the last thing is to evaluate the limit. So as b goes to infinity, for this first part, you're going to have ln of infinity. Remember your ln graph? That looks like this. All right, as you go out towards infinity, it's going to keep going up forever and ever and ever, right? So this goes to infinity. And since that goes to infinity, this series diverges. Oh, let me put by integral test. So you do the improper integral. If it comes out to infinity, it diverges. If you get an answer, then the series converges. Again, it's one or the other. Let's try another one. I know you're all super excited. Just for the sake of talking through it, if you did the nth term test, if you let n go to infinity, what's this going to go to? 0. So no conclusion. Okay. So let's do the integral test. Limit as b goes to infinity, integral from 1 to b, and then again, I always change it to x's, which is usually how you see it written. This one, I will be impressed if anyone remembers this. I will tell you the answer, but does anyone remember what pattern this is? Oh, do you remember it? Go ahead. It is inverse something. Oh my gosh, you're so close. I'm super impressed. It's arc, it is arc tangent. Good. U would equal x, so du equals dx. And then A would just be 1, since it's just a 1 there. Oh, remember, guys, that was a team effort there. So it's limit as B goes to infinity, arc tangent of X. And you're probably like, well, hey, wasn't there a thing out front? And wasn't, yeah, but it was 1, remember? Like if it was 1 over 1, just 1. Arc tangent of X such that 1 to B. So we're going to do upper boundary minus lower boundary, and then we'll evaluate the limit. And again, my suggestion is put the parentheses there because it'll keep you organized. So upper boundary, that'll be arc tangent of B, and then lower boundary, arc tangent of 1, which we're going to evaluate. And now we're going to do the limit as B goes to infinity. I know trig was a while ago, and for you guys, it was kind of a mess. But here is what your tangent graph looks like. Here's pi over 2, here's negative pi over 2. You have these asymptotes, and it looks like this. Do you remember? And then there would be another wiggly thing. There would be like an infinite number of wiggly things. Well, as that goes to infinity, what's the value you're approaching? So as B goes to infinity, this first part is pi over 2. That's what this goes to, is pi over 2. Minus, now arctangent of 1. Think about your unit circle. What would the sides of the triangle have to be for tangent to end up being 1? Because anything over itself is 1. It would be the pi over 4, good. So pi over 2 minus pi over 4 would be pi over 4. We got an answer, guys. We got a value. So what do we get to conclude? Ooh, I'm really glad you brought that up. It converges by the integral test, but not 2 pi over 4. But we're not asked that, so it doesn't matter. All we're asked is, does it converge or does it diverge? Okay, but I have that written down right here. I'm so glad you said that because I wanted to bring that up. Not 2 pi over 4, it will be greater than pi over 4. And if you don't believe me, what you can do is plug in 1, plug in 2, plug in 3, and add up a few of them and put it in your calculator and then type in pi over 4. You'll get a result that's bigger than pi over 4. Okay, all this tells us, since it came out to a finite number, is that the series converges. That's all that it is. Not to pi over 4. So the series converges, but not to pi over 4. It'll converge to something bigger than pi over 4. We don't know what it is, but it doesn't matter because we're not being asked that. We're going to do a couple more. Wake up, everybody. Oh, whoops. Sorry, I'm reading the wrong question here. Or maybe we'll just do, I had 2 more written here, but maybe we'll just do 1 more if you guys feel like you've got it. We'll see how this goes. All right, if you were to do limit as n goes to infinity, you would get 0. This would equal 1 over e to the n. As n goes to infinity, you'd get 1 over infinity, it would be 0. So if you do the nth term test, you get no conclusion, right? So we're gonna do the integral test. Limit as b goes to infinity, integral 1 to b, e to the negative x dx. Now you can write out all the steps for the u substitution if you want, but you're just going to need a negative to adjust for that. So it's going to be limit as b goes to infinity, negative e to the negative x such that 1 to b. And then we're going to do upper boundary minus lower boundary and then evaluate the limit. So if you plug in b, it would be negative e to the negative b. I'm going to write that as the fraction. It would be negative 1 over e to the b power, because we're going to do a limit with that. So I think it's nicer if it's written as the fraction. And then if you plug in 1, you're going to get negative 1 over e. So as b goes to infinity, what does this first part go to? That'll be 0. Negatives cancel, so 0 plus 1 over e, which is 1 over e, which guess what? That's a value because e is a number. And so we can conclude that this series converges by the integral test. But not to 1 over e. I don't know what it converges to, but not to 1 over e. It will be greater than 1 over e. And if you don't believe me, again, you can start by plugging in 1, plug in 2, plug in 3, and add up a few of them, and then type 1 over e in your calculator. It will come out bigger than 1 over e. You're probably like, why is she pushing this greater than thing? Because there's one in your homework where that comes up. And so now I basically told you the answer to that one. It's the one that says greater than. But anyway,